Beginning of graphing. Let's see, I'm going to write in two different colors. In red will be your notes. In black is just me talking.
Alright.
Or do you want to switch it? I don't
So should just write the.
Yeah,
Just
switch
write-
it, because red means bad.
No, just standing.
I just need, because like, I'm going to be like writing stuff and talking about it, but like the only thing you really need to write down is like, you don't need to write everything I'm about to write down.
Alright.
Because I don't know what's going to happen. I wing it a lot. I don't know if you noticed.
That's good. I'm gonna notice.
Right? Especially on this in biology.
We'll just go start off so you can get a header.
Have you guys even
Families
biology?
of functions.
You missed a test.
Hey, bro, I wasn't here yesterday. Bro, can you know? I went in the bus. Like, it's not just me doing the work. It's a whole group thing.
You know what a family of functions is?
Functions in the family.
It's like the mom function and then the dad function and then the... No. There are certain equations that when you graph them, they all kind of look the same. And I think we kind of talked about that when you were matching. Which ones do you know? Parabolas. What's the equation of a parabola have in it?
X squared.
There's one of them. You want to write f of x or x or y? Y. Good old y equals x squared. And the graph of just y equals x squared, what's it look like? A parabola, but where does it go? Do you know?
Wasn't
Doesn't
it
it
zero?
start at 0, 0?
I don't know.
Yeah.
Does it start at 0, 0?
Yeah, because you can't really square zero. It's just zero.
You can square 0.
Well, I mean,
0 times 0 is
zero.
0. All right. So if I plug in 0 for x, what do I get for y? 0 starts right there. As x gets bigger, what happens to y? Does it get bigger or smaller?
As X, what?
Is x gets bigger by...
You guys know what I mean when I say that? I
Yeah.
ask that question a lot.
Y gets bigger.
As x gets bigger, y gets bigger at the same rate?
No.
Yeah.
No, because
No, it's not.
if you have
Wait, no.
like 5 X, you have 25 to Y.
But it doesn't necessarily have to get bigger, does it?
What do you mean?
Or what, like, never.
It's going to get bigger no matter what. You're multiplying that.
Yeah, if we're talking about as I move to the right on the x-axis. This,
Oh, okay, got it.
I can say we can put a context to it. We can put a story. We can say, hey, the x-axis is error, or how far away the projector is, and the y-axis is the area of the screen. And so if I like plug in 0, it's 0. If I plug in 1, it's 1. Plug in 2, it's 4. Plug in 3, it's 9. Plug in 4, it's 16, right? Do they increase by the same amount each time? So this is, as x gets bigger, y gets bigger, but it gets big fast, doesn't it? And that's why it's curved like that. It's not in a straight line. Because the only ones that are in a straight line is when they change by the same amount every time. That's linear or proportional relationships. You know what I'm saying? We need to go back to 7th grade. We should have done
Can we go back to
that. That's why it goes up in a curve. What happens is that x gets negative.
It's still going to be
It's still the same.
positive,
Because a negative times a negative is a positive, right?
right?
So if I plug in negative numbers, they get squared, and so it's basically the same thing as this side, just over here. That's why it's a reflection of itself. Because if I plug in, if I make all of these negative, it's still true. It's still the same thing. So I just come over here to negative 1, 1. So that's why it's curved and it goes up like that. Let's do, and everything with x squared will be some kind of parabola. Next, we're going to shift them around and move them and write different equations, but that's just the basic daddy-o right there. Y equals x to the third, you know what that looks like. I don't know why I'm doing this so small. I have a whole piece of paper here. There's only like 6 of them.
Is it the little squiggly one?
Is it the little squiggly one? Let's think about what happens. See, I'm hoping that you don't just memorize
Oh,
these.
it's,
I'm hoping that you can like think through what happens as x get big and what happens as x goes negative to figure out the picture in your mind if you forget one.
Because if you square it one more time, like x squared is this way because it's still positive on this side. So if you do it one more time, it's negative, so it goes out this way.
I got what
It's
you
like an
I know.
Anyone else got what you
Yeah.
said?
Yeah.
I got
It's
it.
this thing.
What happens is x? Oh, what's the y-intercept?
0.
Plug in 0, you get 0, 0, 0. So it does cross right there. As x gets big, what happens to y? It's big. Here's a question for you. If I put, go into the black pen here. Here's x squared. I'm gonna put x to the third on this same graph. We know as x gets bigger, y gets bigger. Will it be faster or slower?
faster.
Faster, right?
Right there, but then when you multiply it by
Because, I mean, if we compare these two, that one should get bigger faster. Because if I plug in 1, it's, well, pretend those are positive. If I plug in 1, it's still 1. Plug in 2, though, you got to cube it. Now it's 8. So it's going to jump up a lot higher, a lot faster, right?
Yeah.
3 cubed, 27. 4 cubed, 64. Gets big real fast, doesn't it? So this is probably not even to scale. It's probably even skinnier. What were you going to say, Justin?
No, nothing.
But if we go negative, if you cube a negative, negative 1 times negative 1 times negative 1 is? Negative 1. Negative 2 times negative 2 times negative 2 is? Negative 8. So it does this. It's very similar to this, but now it just goes down really fast. So what you end up with is that.
That's what I meant by the little squeeze.
The little squiggly thing. I know what you meant. The snake. Some people call it the snake.
Hey, you remember this one?
Oh boy.
So much more.
This will be coming in the future, but might as well just introduce it right now. If I did x to the 4th, what do you think it would look like?
Wouldn't it be like the same thing but just like
But-
steeper?
Yeah, lighter.
So what?
I mean, steeper. Yeah. Like this way, skinnier.
Yeah. You got x squared. If this is x squared,
Thinner, that's the
Can't
word.
see it.
if that's x squared, if you do x to the 4th, it's the same idea. It's going to get big fast. It just gets bigger faster. And the negatives, if you do a negative to the 4th power, what happens?
Goes positive.
Positive.
It'd be like that. That'd be x to the 4th. If you did x to the 6th, what happens?
So all the even x.
All the even ones
or
look
x
like
factors.
parabolas. Well, I shouldn't say that. It's called end behavior. If you go to the left, it'll go up, and if you go all the way to the right, it'll go up. You will get into crazy ones, and we will do this, where it's like, if you do like x to the 4th plus x to the 3rd plus x squared plus x minus 7 or something, and you can have numbers in front of these. But if you got a bunch of weird crap in here in the middle, the x to the 4th means, yeah, it'll go up to the left and it'll go up to the right, but it can do squiggly stuff in the middle. So it doesn't have to be a parabola. It just means on the left it goes up and on the right it goes up. If it's just x to the 4th by itself, yeah, it looks exactly like a parabola. But you start adding that stuff in the middle, you could have squigglies. We'll figure that out later. I'm just telling you, they, in general, up left and down left. What do you think all the odd ones look like? They look like that one. If you go to the left, they go down. If you go to the right, they go up. They could have squiggly crap in the middle too. But just in general, all the odd powers, they're going to go eventually down to the left and up to the right.
What graph is that called specifically?
What is that called?
Yeah. Is that how the other one's called a parabola?
That's called a parabola. We should write this down.
Squiggly one.
The squiggly one. You know, I don't think it has a name. I think it's just called the cubic.
Parabola?
I might be wrong here, but that's Google.
Aren't you looking at
What is the graph of a cubic function called?
it? I bet you were looking at it.
cubic function, aka a third degree polynomial, blah 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 blah. I don't think there is a name. Can't find anything.
So it's quickly what it is.
The squiggly one it is, or just call it cubic. X up there. Let's see. What's our next one? Let's go with good old square root of x. That's just called the square root function or radical function. I like radicals. Radical, bro. No? Okay. Let's see. Should I pick on people? Test your thinking. Do the random person kind of draw. Alondra. What's the y-intercept? What do you know? How do you find y-intercept?
Oh, if it touches, the point touches the y.
If it touches the y-axis. But looking at the equation, how do you find the y-intercept for anything?
1, 0, something?
One of those.
1,
Would you like to phone a friend?
yeah.
Another question?
Just like that.
0, 0.
How do you know 0, 0?
Square root of 0 is
Square root of 0 is 0. If you want, y-intercept just means where the graph crosses the y-axis. And that always means x is 0. So whenever you want y-intercept, just plug 0 in for x. For anything. Any graph for the rest of your life. That's how it works. Any equation. Now, what you have to do, it won't always be 0. Because like when you get into sine and cosine and stuff like that, the cosine of 0 is not 0. And to make sure I said that correctly. Sine of 0 is 0, cosine of 0 is not 0. So that's in the future though. Stay tuned. Yeah, it starts at 0, 0.
I think it goes up really slow.
You feel like it goes up slow? Why do you feel like that?
Because you go 0, square root of 0.
Let's just make a little table here, see what happens. Go into black.
The bigger the x,
0, 0, 1 is 1, 2. I know it, it's 1.41.
Okay.
3, I don't know.
These are created.
4,
2,
2, 5, 6, 7, 8, 9, 3,
It goes up really, really, really.
10, 11, 12, 13, 14, 15, 16, 4. Yeah, look, it gained 1 right here in the first step.
so
But then to gain another one took 2 more steps. To gain another one took 5 more steps. To gain another one took 7 more steps.
It's gonna have a little arc and then go.
Yay, remember the balloon graph?
Yeah.
It goes up kind of fast at first and then it kind of levels off. And it just keeps on going up slowly and slowly and slowly as you move to the right as x gets bigger and
What
bigger
is
and
that
bigger.
called?
Square root graph, radical graph. I don't think it has a name either actually. Actually, I think only more of them has a name. Oh, okay. We're going to go there next. What happens when x is negative?
y is positive.
Really?
because it'd be
What's the
I-
square root of
because
negative
it would
1?
be- Isn't
Negative
that
one.
I?
I. There's no I-axis. We're not going to graph. You could graph them,
How
but
can you graph an
you have to do an imaginary axis and a real axis, and it's called polar coordinates. Pre-calc. I don't really like it.
Shit, I'm just gonna go back to the regular math.
Can we just
Because it's my class, and I get to do what I want. Yeah, negatives. So there's nothing over here. What's the domain of that sucker then?
X is greater than
It's,
0.
greater than or equal to 0.
Greater than or equal to 0 only. And there's nothing over here, because if I plug in negatives, it doesn't work. So that's it. We've traditionally called that the sprinkler, because it's like a sprinkler shooting water. I don't know. I was going to Google that all day. What is the graph of a square root function called? Ooh, this one has one.
Function contains a radical expression with the independent variable in the radicand.
Well, they just call it radical function. It doesn't really have a name. We'll just call it radical. It's pretty awesome.
Can we call it?
Sprinkler?
I know, I'm supposed to drink like 6 of those water bottles.
What's next? feel like I'm forgetting one. Let's go with this guy. Oh, let's do the third root. So all the similar to parabolas and cubics, if it's an even number in the index of the radical, ooh, remember those words? If that's even, they all look like that generally. But if it's an odd, like the third root of x, what do you think happens? What's the y-intercept, Breeze? 0, yeah. As x gets bigger and bigger, what happens to y?
It keeps getting smaller.
Bigger.
Okay, the value of y gets bigger, but the rate at which it increases
It's smaller.
is smaller. Oh, we're almost starting to think like calculus kids. This is good.
How great.
There's two things to think about: how it changes and how fast it changes. That's good. So yeah, it's going to look very similar to that, just not go up as fast. But guess what? Can you do negative third roots of negative numbers? You know what the third root of negative 8 is? Negative 2. Because negative 2 times negative 2 times negative 2 gives you negative 8. You can do third roots of negatives. You can do fifth roots of negatives. You can do odd roots of negative numbers. What is the third root of negative 1? You're going to be on YouTube.
Negative 1.
Negative 1. What's the third root of negative 8? Negative 2. So what happens is it just goes... It's like that guy tilted and flipped.
So it's a sideways squiggle.
It's a sideways squiggly. That one's actually a snake. Cynthia. Well, I'll let you answer. Alright, Alejandro wants to talk to you.
Do you guys have tissues? Alright, thank you.
These are still radical functions. Anyway, any questions? Feeling it? Will you have to know what all these look like? Yes. That's all important. What?
What? I didn't know.
I'm just messing with you. Yeah. It'll be on YouTube. I feel like you need to go back and review. Absolute value. This is the easiest one. Sometimes. Let's go over here to this row.
It's always going to be positive.
What was the what?
What was the other graph called?
Third root one? It's just a radical graph too. It's just a, the one was the odd roots have that other part.
No. Yeah. It'd be a V.
Jacob, what's the y-intercept?
0.
Good job, Jacob. 0. What? When x is 1, what is y?
1.
When x is 2, what's y?
2.
When x is 3, what's y?
3.
Oh, this sounds like something we've seen before in 8th grade Algebra 1. If we go to the right, what is it? It's just it's a straight line. Because every time x goes up by 1, doesn't y go up by 1? That's a linear relationship. They go up by the same amount every time. It's just a straight line. When x is negative 1, what's y?
1.
When x is negative 2, what's y? Negative 3. 3. So what happens over here?
Straight line going up.
It's a v. Easy to remember. Absolute value.
Can we just put the Z line?
The v.
The V.
The v.
Big V.
And it's a v. People call parabolas v's sometimes, and I'm like, no. Those are curved. It's more of a U, kind of, but they never go straight up. I don't like to call them a letter, because they're not. They're crazy. They're parabolas.
So no,
That is straight up a V. It comes down, it ends at a point. It's not curved. It is like a sharp edge. It's a V. One more. The hardest one to think about. Who thinks they're smart? Let's leave it to chance. What are you doing? Huh? Oh, I didn't see who that was. Too many red marks. Sarah's not here. Vicente! What's the y-intercept?
1 divided by 0.
Good answer, Vicente. Good answer. You can't divide by 0. So what do you think the y-intercept is?
There is no error.
There isn't one.
Oh, it's that one that starts like.
It's the racetrack one. It's 200 divided by x. And now this is just 1 divided by x. That just changes the pitch a little bit. But yeah, it's 0. Or it's not 0. There isn't one.
What's this graph?
This is called a hyperbola.
Hyperbole?
Yeah, this has a name.
So how would you graph that? Because so it can't be 0, but it could be like 0.0003.
It could, yes.
So
And it could be 0.0000000000000000001.
yeah.
Yeah.
So would you have an open circle on 0, 0? Because it could include like 1,000, blah 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 3.
Hold that thought. Let's plug in a few numbers in our heads.
If they lose.
Come over here and make a table if you want.
No, not even.
No,
Even if they lose today, yeah.
When x is 1, what is y?
Error. No, 1.
1. When x is 2, what is y?
1/2.
Half. 3.
1/3.
Third. 4.
1/4.
Fourth. 5.
5th.
Fifth. 100.
100.
100. A million.
1 million.
1 million. Will it ever get down to 0?
1 trillion.
No. Okay, so, well, if we go to 1, 1, put some numbers on here, it's just going to drop down like that forever.
But that graph says it starts at 1.
Okay, so let's go,
1 million.
what's between 0 and 1? What kind of numbers do we know?
1.1.
Oh, fractions. Give me a fraction.
Half.
A half. When x is a half, what is y?
1 divided by 1 half. I don't know.
4?
1.
Wait, I don't know.
1 divided by 1
I
half.
confused myself.
Thank you. You said is going to get chicks in college. 2. You can do fractions in his head.
Yeah,
1 divided by half?
Oh,
Yeah.
duh.
1 over 1 half. 1 times 2 over 1. It's 2.
Oh, yeah.
What's about a third?
1 divided by 1.
Huh? 6?
I don't know.
1.5.
I can't divide. 3.
Wait, no, it's a third. 3.
No.
3. 3. What about
So, 1 is 4.
a 4? 1/5. 5. 1/100th.
100.
100. 1 millionth.
1 million.
1 million.
1 mile.
So back to the graph.
Okay, so back to the graph. Look at, notice I went in decreasing order, so I moved towards the y-axis. It's just going to get bigger and bigger and bigger the smaller the fraction gets. So when you divide by a fraction, your number goes up. So if you divide by a really, 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 really small fraction, you get a really, really big number. So it's just going to go up and hug that y-axis all the way up. Never touches it though. So kind of hard to draw, but that's the idea. There's an imaginary line right here. Actually, there's two. There's one right there, and there's one right there.
But there isn't.
Did I tell you what those imaginary lines are called?
No.
We didn't talk about this?
No.
Well, I think it was Algebra 1. I told them about it. I was just talking and like getting on a roll. It's like, you guys don't need to know this, you know? Those little dotted lines, those are called asymptotes.
That's funny.
The definition is it's an imaginary line that the function approaches but never touches.
Can you repeat that?
Yes, I'm the lights on when it's done writing. In the corner? Hello? Yes. Okay. asymptotes, imaginary lines. They're usually represented with dotted lines on graphs that these get really infinitely close to but never actually touch. Well, that's not 100% true. You get to pre-calc, you'll find out you can cross horizontal asymptotes, but you can never cross a vertical asymptote. It's getting hardcore there. You don't need to know that in this class quite yet.
Yeah.
Vertical ones, though, the reason vertical asymptotes exist is because there's something in the function where you're dividing by 0. More on that later. We will do like 2 weeks on this guy. Sucks. It's hard. This graph isn't complete though. What haven't we done yet?
Can't you do the same thing in the negative?
On the negatives, yeah. Well, how's it going to be different? Is it going to be up here or is it going to be down here? It is down here. Because 1 over -1 would be -1. 1 over -1/2, -2. It just makes all these numbers, all these y values become negative on the negative side. So you're just going to be like that. Now we might as well do one more, just because you guys are advanced. 1 over x squared. This will be the last one, I promise.
Tell me about the last one.
Well, then I just remember stuff, and I add. Can you draw that without me telling you what it would look like?
It's not going to touch the y-axis.
It's not going to touch the y-axis, that's correct.
1, 2, 2, just like,
Close to the same thing, huh?
but just like closer to the line or something.
Yeah, I know what you mean. It's going to be like, it's hard to draw. You can't really,
Yeah.
if you put them on top of each other, this one would get, let's see, when x is 2, y would be 1/4 instead of 1/2. So it gets smaller faster, and it gets bigger faster, but that's really hard to draw. So essentially, it's just going to look the same right here. I mean, like I said, if you put them on top of each other, you would see a little bit of a difference. But the big difference is over here. What do you think?
2 times 2.
Let me pick on somebody. I like picking on people. It's a brain thing. You scared, Aubrey? It's all fake. Keep hitting high on the list. I got it in lower. There we go. Who's that? Salvador's not here. Bianca, you're the winner. What do you think is going to happen over here on the negatives? Mirror it like this. Mirror it where? Over what?
Or the y-axis.
Plug in -1. What do you get?
1.
1.
It's positive.
Yeah. It mirrors it over the y-axis. It's like this. And it'll never go negative. My drawing is poor. It should be a perfect mirror image of itself like that. Again, never touches. When x is 0, though, you can't do it. So there's an asymptote here. It gets really close to that y-axis, infinitely close. Just zoom in, though, and there's still a gap. Zoom in, and there's still a gap. That's still a hyperbola, I think. I could be wrong. I'm known to be wrong with my words.
Hyperbola squared. I don't know.
Hyperbolas. There's lots of different kinds of hyperbolas, actually, so it's probably still a hyperbola.
You got all the notes.
So those are the main things. No, we're going to start shifting now. Now we're going to actually, like, well, maybe we shouldn't. No, this is easy. Let's just do parabolas right now. Actually, it's all the same for all of these. You can write. I'm trying to think how I can explain this in 10 minutes.
You can just do tomorrow while you leave.
Nope. Got it. I thought. You know how I told you could write, you could have big old long ones like that?
Sure.
But there's also ways to write these that are all similar. It's called, well, let's just focus on parabolas right now. I don't think they were written this way in your matching thing. We might play a computer game tomorrow. It'll be fun. I need more letters. I'm going to make it harder. I want to get you guys closer to pre-code. We're going to go algebra 2.5.
Just one as well.
Well, usually it's a times x minus h squared plus k. Pre-code for you.
And then it's algebra.
No, then it's calculus.
Then it's algebra.
You ain't going to do algebra 3.
You don't have to?
No.
Why? What's algebra 3?
Algebra 3 is I still don't know how to graph a line, and I got a D in algebra 2, so now I need to go to algebra 3 because pre-calc will smoke me. That's algebra 3.
I need to go to
The other reason to do it because
Several of you in this class will go to algebra 3 next year. It's not a given thing. Pretty much, if you get less than a C, probably shouldn't go to pre-calc. It's freaking hard.
I have C right now.
Yeah, what do you have to see?
I don't get less than
I don't. I have a B.
I have an A or a B, maybe a B.
We're close
not the
to
hard
C.
thing.
Yeah, we're close.
We're close.
You said less than.
We'll start easy. I'll kick it up a notch later.
You get a D. Or C minus.
We had to find a graph for that.
Oh, no.
I got that. What the heck?
Dude, like, I barely even know how to do plus 2. Plus 2.
This is easy.
For you, because
For you too, in like 3 days. It'll take like 3 days. And then you'll be like, oh, I get it. It's really easy.
No, it would take me like 2 weeks.
Is this a parabola with a y-intercept?
Okay, watch. You can write that down. I'm going to black pen for a little bit here. We're gonna figure out what each. We're gonna figure out each of these letters will be numbers in the future, and they have an effect on the graph. If you change this to a big number versus a small number versus a negative number, it does different stuff to the graph. Same here and same here. And if we just go step by step, it's really not difficult. The easiest one to think about is probably the K. So we'll start there.
Isn't it y?
Okay, the winner.
It is not the
X
y-intercept.
intercept.
Always. Because here's the deal. You're going to see some that look like this. Is the y-intercept 3?
No, it's 2.
No?
You have to figure
It's the
it out.
parentheses.
You have to go 0 minus 4, which is 4, negative 4, squared, which is 16, times 2, which is 32, plus 3, the y-intercept is 35. It is not listed. It's not y equals mx plus b anymore, folks. It's when x is 0. But if we just go like this and we ignore all the other numbers, and I just do x squared plus 2.
X is 2.
Y-intercept is 2. So here's the deal. We're going to graph. I'm just going to show you. Here's regular old x squared. If I do this one now, I should write that in black. If we just go x squared plus 2, what's the y-intercept become?
2.
2.
The slope is the same.
The slope or the growth rate, don't say slope, slope is just lines.
Same.
It gets bigger at the same rate, right? If I made a table for this one, 0, 0, 1, 1, 2, 4, just squaring everything, right? 3, 9. How is this table going to be different? 0 is 2. 1 squared is 1 plus 2 is 3. 2 would be 7. 3 would be
Wouldn't that be 6?
Because 2 squared is 4.
6. Yeah, I don't know how to add.
12.
11. Look at the difference. Isn't every y value just getting 2 added to it? Doesn't that make sense? Because you do the same thing, except on this one at the end you add 2. So all of the points, what happens to all of my points?
They increase by 2.
They all go up by 2, don't they? So every point along this graph now just gets shifted up 2. And so you get the exact same parabola just shifted up 2.
Wait, you go back to the first.
The big one? If I made it x squared minus 3, what do you think would happen?
You would subtract 3.
Did you notice? Remember when you did that big old packet that I never collected that we never did anything with right before Christmas break, and you're supposed to graph the 3 parabolas in the 3 different colors?
Yeah.
Did you notice a pattern?
Yeah.
If you just subtract 3, what will the y-intercept be?
Negative
3. And then isn't it the exact same as this, except now I just minus 3 from all of these?
Yeah.
So aren't all of the points on the graph just going to go down 3?
Yeah.
Okay. That's what k does. Any number added or subtracted on the end will shift it up or down. The graph. If you had a table of values, it just adds or subtracts that much to all the points, to the y values. We'll do graphs first, then we'll do tables, because in this case, graphing is easiest. Dang, we're not going to get to the 4. Or,
Sad.
Or not.
What a shame.
Oh well.
My heart just broke. There's no more math.
or we stop here, I give you part of the homework so you can get it done.
No.
So I've been putting it off.
What if I don't understand it? We barely, you just gave us like 5 minutes to take everything in. I need like 5 days.
We'll continue these notes tomorrow. I'm going to give you part of your homework right now.
No.
Can we just like zone out?